Welcome to Get Your FRQ On. This question is from 2022. It's question 1, and it is calculator active. In the question stem, we are considering times between 5 a.m. and 10 a.m., and we are considering the rate at which vehicles arrive at a certain toll plaza, which is given by a function a of t, where t is the number of hours after 5 a.m. and a of t is measured in vehicles per hour. Traffic is flowing smoothly at 5 a.m. with no vehicles waiting in line. In part A of this question, we are asked to write an integral expression for the total number of vehicles arriving at the toll plaza from 6 a.m. to 10 a.m. They're even kind enough to remind the student that 6 a.m. would be t equals 1 and 10 a.m. would be t equals 5, so there's no mistaking it, and they don't have to do that themselves. Note that we are only required to write this integral. We do not and should not evaluate it. If we try to evaluate it and we get a wrong answer, that may cause us to fail to earn a point, and we don't want to give points away. The total number of vehicles arriving at the toll plaza will be the integral of the rate function. So the integral we want is the integral from 1 to 5 of a of t dt, which is the integral from 1 to 5 of 450 times the square root of sine of 0.62t dt. In part B of this question, we are asked to find the average rate in terms of vehicles per hour that vehicles arrive at the plaza from 6 a.m. to 10 a.m. So the average rate would be the average value of the rate function over the interval from 1 to 5. So we have the integral from 1 to 5 of a of t dt times the reciprocal of the length of that interval, 1 over 5 minus 1. So we have 1 over 5 minus 1 times the integral from 1 to 5 of 450 times the square root of sine 0.62t dt. This is a calculator active question, so we're going to use our calculator to evaluate that, and we get 375.537. And so the average rate in vehicles per hour that vehicles arrive at the toll plaza from 6 a.m. to 10 a.m. is 375.537 vehicles per hour. Make sure you use the correct unit here. They do specify that in the question stem, so you do need to use that. In part C of this question, we are asked to determine whether the rate at which vehicles arrive at the plaza at 6 a.m. is increasing or decreasing. Whether the rate at which vehicles arrive at the toll plaza at 6 a.m. is increasing or decreasing depends on the value of a prime of 1. And since this is a calculator active question, we can use our calculator to evaluate a prime of 1. Using our calculators to evaluate a prime of 1, we find that it is equal to 148.947. Note that that is positive. And since 148.947 is positive, the rate at which vehicles arrive at the toll plaza at 6 a.m. is increasing. In part D of this question, a line begins to form at the toll plaza, and we're given a function n of t equals the integral from a to t of a of x minus 400 dx, which describes the number of vehicles in line at the toll plaza. And we are asked to find the maximum number of vehicles that are in line on the interval from a to 4. Now, because this is a closed interval, the maximum number of vehicles in line at the toll plaza will occur either at an endpoint or somewhere in between this value of a and 4, where the derivative of n of t is 0. So we have n of t, which is the integral from a to t of a of x minus 400 dx. And because of this, we know that the derivative n prime of t is just going to be a of t minus 400. And since we're looking for a maximum somewhere in between where n prime of t is equal to 0, we need to know when n prime of t is equal to 0, which we can use our calculator to find. So n prime of t equals a of t minus 400 equals 0 implies that t is equal to 1.469372 or 3.597713. And for the purposes of this question, we're going to define a to be the first value, 1.469372, and we're going to define b to be 3.597713. So evaluating our function n at a, the integral from a to a is just going to be 0. It's a calculator active question, so we can use our calculator to find n of b, that is 71.254. And we can use our calculator to find n of 4, that's 62.338. And based on these results, the maximum number of vehicles in line at the toll plaza for values of t between a and 4 is 71. If you like the AP Calculus free response question solutions and want more of them, don't forget to like the videos, subscribe to the channel, and you can also find me on X at x.com/getyourfrqon.